Hello everyone, coming back to the discussions on Buchholz relay and the practical applications of this relay in real life. This is what you see. We know that Buchholz relay, being a gas actuated or a gas operated relay, is installed in all transformers of rating 500 kVA and above. But we never said that it is installed in reactor or in NGR also, in your neutral grounding reactor, because the reactor, this is a 50 MVAR line reactor. So when this reactor is there, then in this NGR is also installed along with the line reactor, because you cannot have just this line reactor, because then in case of a fault there will be huge flow of current that may damage the winding of this neutral. So in order to compensate, or in order to limit the current, we are installing this NGR, neutral grounding reactor. The job of this is just to limit the fault current. It has nothing to do other than limiting the fault current in case of fault in this transmission line. So our purpose here is to actually see where is the locations of the Buchholz relay. So here also in this NGR, neutral grounding reactor, this Buchholz relay is installed. And where it is installed, where is the location? It is installed in between the conservator tank, this is the conservator tank, and your main tank. You have there Buchholz relay. So if there is any fault inside this, because of heat or because of winding, maybe that winding that we are able to see now is directly going to earth without actually passing through the winding. So if that is the case, then the oil inside will get heated up, and that will lead to generation or production of gases like methane, hydrogen, oxygen, also to some extent carbon monoxide, carbon dioxide, methane, and then these gases being lighted, and oil will rise up and will try to reach the conservator tank. And while doing so, few of the gases or some of the gases will get trapped in this relay. And the construction of this relay has been made in such a way that the trap air inside will replace the oil, will keep pushing the oil down, and because of which the float on top of the relay inside actually, but just have been installed just a little bit up, will be actuated, shorting and giving you alarms. And if the fault continues or the fault is severe, then the air will keep pushing the oil upside down, and then a point will reach that the float, the second float, which is at lower level, will also be actuated and giving you a tripping command, tripping signals to the breaker, and the breaker will disconnect the reactor or the line, in fact. So this is how it is installed in between, always in all whether it's a reactor or a transformer. Only one basic thing is that it is installed in between the conservator and the main tank, and that's all. No matter where you install it, but it should be between the main tank and the conservator tank. And also one thing, that it should incline at an angle of 2 to 5 degree towards the conservator tank. And this company, the company of this, I think it's Sidaspe. It's quite a good company. The contact used inside also, it's not a mercury switch that we used to if you see in, or if you read that you keep telling about mercury switch, but that is a magnetic switch, because it's more reliable. Because in case of mercury switch, if you use mercury switch, then there is a possibility of the contact shorting because of vibration, maybe due to earthquake or something. So in order to avoid that, it's always good to have magnetic contact, and that is what it is being done in all the Buchholz relay used in a power transformer. So this much only, I think, for today. Thank you.